for joining our webinar. So today we want to spend some time talk about the real-time data plus AI, search recommendation and beyond. So I'm An Wu, and typically in the past, I probably spend a lot of time right while doing presentation or participate as the panelist. But today, more like a moderator. I will probably join the conversation, but however, I would like to have you guys to share more about your opinion, okay? Um, so yeah, it's just real-time data and AI. I will definitely give you enough time to, I mean, t talk a little talk about our products, but let's focus on I'm pretty sure that we can share our opinions honestly, right? No need to have all kinds of promotions, but we're just honest for the discussion and feel free to raise any questions if anyone have. Okay. So about the agenda, I will definitely give you time to yeah do a self intro. Okay. For the in this webinar, we were yeah definitely we after doing a self intro, we can discuss something about real-time AI use cases. We can start with the use cases, and then let's talk about the rack because well, I know that well, yeah it's some people really love about the rack, and then AI pipelines, right? And then after that, we can discuss more about the architecture, right? We know that nowadays what people talk about, okay, S3, let's build a search engine on top of S3. Let's build a vector database on S3. Let's build a database on S3. Let's build everything on S3. We can talk about that later after what. All right, the first question, let's just warm up. Can you give a quick intro and about yourself and probably the company, the product, and give a brief pitch for the product, okay? So let's find who goes first. Sijie, you want to go first?
Sure. Thank you. Thank you, Eugene, and thanks like RisingWave for having me in this panel discussion. So my name is Sijie Guo, one of the co-founders and CEO of StreamNative, also one of the original creators of an open source project called Apache Pulsar, which was originally designed as a unified messaging and streaming platform coming out from Yahoo. We kind of providing fully managed services, fully managed data streaming services on the public cloud. Recently, we kind of introduced our next generation data streaming engine called Ursa Engine, was natively built on top of S3 and have a deep integration with both Iceberg, Delta Lake, and also integrate with data catalogs for unified governance there. And really glad to be here to talk about real-time data and AI. There, looking forward to that.
All right,
Pass
thank
on
you, thank
to
you. And
the next one.
who want to go next?
Yeah, I can go. Hi guys, my name is Rayees Pasha. I lead the product team at RisingWave Labs. RisingWave is a streaming database. The way we position it as a amalgamation of a product that combines the stream processing capabilities with the interface of a relational database. Um, Think of us like Flink plus Postgres in one solution. Now that's our core competency. Having said that, we're adding many more capabilities to the platform, deep integration with Iceberg, with catalogs. There's a lot more. Will probably take more time for me to go over. Looking forward to this topic here today, real time search and how stream processing and AI, the convergence of which is sort of the future for a lot of use cases. So looking forward to that productive discussion.
Okay, cool. And then Chang.
Yeah, thank you, Jing. Super excited to be here today. Hi, everyone. My name is Chang. I'm the CEO and co-founder of LanceDB. We're the database for multimodal AI. We have a new data format for AI that's optimized for both fast scans and fast random access, and the ability to work with large binary blobs. So whether you're building AI applications or AI models, you can store your data, all your data in one single source of truth. And you can use LanceDB on top for infinitely scalable search and retrieval, and much easier and more productive and scalable training pipelines, analytical workloads, and feature engineering as well. So,
Cool.
a little bit about myself. I've been building data tools for machine learning for about 20 years at this point. I was one of the original co-authors of the Pandas library, and I started LanceDB about 3 years ago because I saw, if your data fit neatly into a data frame, your life was decent. But if you were working with AI data, from embeddings to text to images and videos, there weren't a great set of tools, and the data infrastructure wasn't built for you. And that was the mission that we started LanceDB with.
Cool, cool, cool. Thanks for sharing. And the next question I have, basically a one-part question. Why build a product now instead of a decade ago? I know that's what, yeah, all of our companies, right, well, haven't been there for several years, so it's definitely not, well, I mean, build a brand new product in 2025, right? But look, well, my question is more about, okay, how your domain looks like, well, today, right, compared to, let's say, 10 years ago. Yeah, Chang, you mentioned that you have been building the machine learning a platform for 20 years. And could you please share more about I mean, the domain, what changed in this domain, right? And
Yeah,
why you build something like LanceDB instead of like, okay, let's go through, we can probably keep working something like pandas, right? Yeah.
right,
Give me
right.
an answer. Yeah.
Yeah, absolutely. So, if we're talking about a decade ago, right, if you think about machine learning, it was a lot
Hmm.
of financial use cases, recommender systems, maybe like anomaly detection, security, fraud detection, autonomous vehicles was just getting started. And so the vast majority of production machine learning cases were based on um, based on tabular data, or maybe semi-structured data that you get from clickstream, but then you form into structured tables. And it was fairly nascent to have these like very multimodal AI heavy use cases. And obviously the past couple of years have completely changed the landscape, and the need for a better way to store, query, and manage all of your AI data has just exploded at a pace that like kind of dwarfs previous waves of technology. So in a nutshell, I think that's why we're building our product now, instead of 10 years ago.
Hmm. So in 10 years ago, you didn't really see any demand for, I mean, building some library for unstructured data, right? What do you think?
It,
What do you mean?
the niches were there, but they were
Hmm.
not nearly as ubiquitous, and the structured data tools
Hmm.
and data infrastructure weren't nearly as good. So that I think if I were to go back 10 years, the product I would build would be very different. I would build towards more like structured data solutions, because at that time that's what the market needed. That's my opinion, at least.
Okay. Okay. Yeah, yeah, yeah. I could imagine that. Well, because well, I still remember 10 years ago, probably people are still talking about, well, I mean, XGBoost, well, those kind of things, right? Yeah.
Yeah,
Okay.
exactly. I mean,
Yeah.
I think that Boyan Tungus still talks about XGBoost is all you need on Twitter all day. So, like
Oh, yeah,
20,
yeah, 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 yeah.
yeah,
That's
yeah,
right.
and 2015, like Cloud BI was barely a thing, right? And like there are tons of like streaming data infrastructure that weren't there. Iceberg wasn't a thing, and there were tons of things that were missing in kind of that traditional tabular data infrastructure land.
Yeah, yeah, cool, 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 cool. Yeah, yeah, yeah. That's yeah, yeah, definitely. I mean, it's already been 10 years. I couldn't imagine that. Okay, the landscape has really changed so much, right? And for race, and what's your opinion? Like you have been working in data infra domain for I don't know 20 years, right? So
Yeah.
like what changed?
To me,
You don't need to
if
compare it today with 10 years ago, but we'll compare with probably a decade ago. Yeah.
yeah. So I mean, in the data base field, it's like back to the future. Some of the things that we used to do for 20 years back, we're trying to do it again. So in a way, it's like circular. But in terms of the product we are building here at RisingWave, right? If I had a time machine, I would go back and build that in 10 years ago. That would solve a lot of problems with the first generation stream processing systems, right? Because we are trying to address those shortcomings. In a way, why is it the moment now is part of it is business, like that the business application that people are building are requiring kind of functionality that we provide in terms of low latency, in terms of basically um, uh, eh, not be held back by the tech that you have. Like, for example, when I talk about RisingWave to our prospects, usually the use case fall into two buckets. One is the new age applications, greenfield applications that were not even possible before, versus the second bucket, which is legacy applications which are built for batch,
Mhm.
and there's a migration path to streaming available now. So the latter is all possible because of the fact that allow the new product, that the technology that is available today for us to build makes that possible. So in a way, I guess the core rationale for another database, like there's literally hundreds of databases. Why do we need another one? Is the fact that there is a path for a unified processing model, which is streaming first approach that was not possible before. Earlier, batch was the default and streaming was
Yeah.
your niche, right? That conventional thinking is no longer true. Now you can do a lot of the things, majority of things with the streaming first approach. And that's why you have this shift left, Kappa architecture, you're talking about medallion architecture. All of these are about pushing your data processing as far as left earlier in the cycle was possible, right? Those kind of things are basically what are championing products like RisingWave, in my opinion.
Mhm. Mhm. Cool, cool, cool. Thanks for sharing. And Sujie, yeah, in your intro you mentioned okay you are one of the original creator of Pausa, right? And definitely well, I don't know when Pausa was created, but tell me more about that. And
Yeah.
what changed? Yeah, I think that project definitely changed a lot, right?
Sure. I think in general in the messaging and streaming space, it has evolved and going through multiple evolution there. I think to get started, I think Reyes mentioned about stream processing a couple years ago. At that time, I think that is probably prior to kind of having Kafka as the kind of the popular standard for data streaming. I think everyone is using different messaging queue for like a service bus for asynchronous communication. And then the rise of needs of okay, we're looking into faster like data inside. I need to move data from a surface A to surface B, ingest data into your Hadoop batch processing, and that's kind of where Storm and a bunch of the other kind of stream processing engine was coming up. And at the same time, I think while you have the stream processing capability, you need to move the data, and where that was kind of Kafka was born. And at that time, I think we are living in a situation is from 0 to 1. And the entire design was more looking into how we can optimize and minimize the kind of data movements because the networking was slow there. So the Kafka design was kind of more coming from uh, I need to run the infrastructure, collocate the storage in the serving or the compute layer together. But quickly with the rise of the stream processing, Kafka also became one of the de facto standard from a protocol layer perspective. Um, it has been kind of being the dominator as for data streaming infrastructures there. However, the entire infrastructure has been moving towards more cloud. Networking became much faster, but it also became very expensive. So if you're looking into your data infrastructure expense, like 80% or 90% of your Kafka cost was coming from networking. And from that perspective, because the entire economy kind of going into towards a downturn, that is people looking into cost cutting or cost control. And so how you can leverage the kind of modern cloud, like with object storage, with the rise of the lake house, how you can leverage those modern infrastructure primitives, building a new data streaming engine became important. And that was why I think it's an exciting moment to kind of comparing to 10 years ago. You don't have these primitives like object storage, you don't have lakehouse, you don't have open standard, you don't have data catalog. So we kind of rethink in the modern, like in now, like what is the data streaming engine will look like? Can we leverage object storage? Can we leverage open table format? Can we have integration natively with data catalog for unified governance? And that's kind of how we kind of come up with this like new data streaming engine there that purpose built for this decade. And I want to kind of maybe add on one more addition to the kind of the large background is the I think a year ago, if you're asking me about data streaming, what is the relation between data streaming with AI? I think at that point of time, I think AI is more all about training model, and data streaming at that point is not quite relevant because you can use batch for ingestion. You can use it doesn't really need streaming. However, I think as we're moving into this year, I think a lot of this going into inference, going to agent, and where I think data streaming, real-time data, fresh data, I think became more and more important, and how like data acquisition and how cost effectively to fit in model with fresh data, how you can acquire data kind of in a much lower cost, I think became really important for this for now especially.
Yeah, cool. Yeah. Definitely. Yeah. Nowadays, I think compared to 10 years ago, yeah, definitely you have a better hardware, you have a better application, you have better, uh, yeah, better the standards, right? So the open standards, right? Yeah, it's amazing. Couldn't imagine how things moved for over the last 10 years. And Sijie, you mentioned about the AI, and then let's talk about yeah, something real, right? Well, this webinar is about real-time AI and data. And so the next question I have is, can you give me a real example about real-time AI applications? So look, I really want to discuss about well, the real world example, right? We don't really want to talk about something like, okay, just a fake example, right? So I guess for among all of us, well, Chang is one of the best persons to answer this question because well, he's building LanceDB, and LanceDB has already been adopted by so many big companies. Like I think well, this week I saw you publish something about Harvey, right? For the legal, right? Well,
Yeah.
yeah, you can talk more
Yeah.
about that. But well, I mean, and also I mentioned Databricks, right? For Databricks, it also adopted LanceDB internally. So can you give? But I want you to share more about real-time AI. So can you give me some applications, some examples, and tell me how your customers leverage the data streaming and AI together?
Yeah, absolutely. I mean, I think there are tons of kind of new and expanded real-time use cases for AI. And some of the ones that you guys are probably already familiar with, like RAG, if there's a chat interface, the chat history and the information, the context that a user might provide needs to be part of the real-time decision-making process of your AI application. Every app, right, has a search box, but they all suck because in the previous generation there was no ubiquitous kind of semantic search, and it wasn't all that easy. And so I think we're seeing now is this wave of adoption where most of those search boxes are now going to be replaced by semantic search rather than just full text search. And so, semantic search applications are also fairly real time as well. And then, there are, I think this year, especially with agentic applications becoming much more mainstream, right? If you think about use
Yeah,
cases
can you describe more about explain more about the agentic application? Because I believe that's not everyone understands this kind of the buzzwords, right? This is the latest buzzword. Yeah. Tell me more
Right,
about that.
right. Um, I guess like the simplest and the roughest way to describe it is basically an agent is, you can think of an agent as like an LLM and a for loop. And basically you have a more complex task that you want the AI
Mm,
to accomplish, and a direct call to the LLM isn't sufficient. So an AI agent essentially creates a cognitive system that breaks down the problem and uses LLMs and also a retrieval at many different stages, and potentially has feedback loops to complete the overall task. And this can be simple agents to like very, very complex agents. And the degree to which there's a spectrum of how real time that becomes, right? So LLM
mhm.
calls can be expensive in terms of time. So the more complex, the longer your agent chain becomes, then the less real time it gets. But I think for a lot of companies these days, what they find is that to better serve their customers, they need a mix of these like simpler versus more complex agents that then they have to balance between the latency in real time, the quality, reducing hallucinations and things like that. And that's a very, I think, is a very active and ongoing field of experimentation today.
Yeah. It actually reminds me of one of the applications I worked with as well. So they built something called the so called a proactive agent. So it's also about the agent, but for the thing here that's what it worked with it's more so basically what you talk about was that okay probably they have the slow thinker and a fast thinker right and right
Exactly.
and things like that. And
Exactly.
so yeah, the case I used to work with was that well, they actually have the proactive agent, which means that well, they actually so it's a e-commerce for use case, and in the
Right.
e-commerce they actually want to identify the user behaviors and then give recommendations. And actually, it's more complex than just an ad. But it's yeah, they build up actually agent, so-called agent, or easier to understand. It's basically a bot, and they actually use the user behavior log and do the real-time analytics and then feed the log into the agent. No, yeah, basically build a rack, real-time rack, and
Yeah.
then use
Yeah.
that kind of information and to feed into the bot. So that's where the bot can give a better recommendation to the product. So yeah, that's I think probably that's something I don't know whether it should be called like agentic or right for but for I think probably definitely similar, right? Relevant, right? Yeah.
Yep. Absolutely.
Okay. And Riz, can you give a pretty yeah, we have already
Yeah,
spent 30 minutes, but well, yeah, can you give me some examples
yeah,
of
so I'll try to
the
keep it.
real-time AI applications? Yeah.
Yeah, I'll try to keep it brief. I'll lean on one of our customers, like RisingWave customers, who is using sort of for RisingWave for real-time applications. Um, it's a talent acquisition company. They do matchmaking for candidates versus job offers, right? This is a problem where you have folks updating their profiles, adding new profiles, new job postings coming. Earlier, they used to rely on batch model, where they would basically match candidates based on data that was at least 1 day old, 2 day old, right? Now with Rising Way, with all the real-time way they process the data, it actually has shortened the windows to a few minutes, like how fast the model gets updated, right? In terms of their model scoring and improving the accuracy of the matches for the candidates versus the job specifications. So in a way, it's a very traditional old application, not like I said, something that wasn't done before. It's just that the accuracy is better, and the model performance is better, all because you have sort of a real-time processing is adding that dimension to this application. I
Are they
have
using LLM to do the recommendation or what?
recommendations and they do the matchmaking in terms of like for a particular job, or posted by an employer, what are the best candidates, right? So that sort of matchmaking they're able to do
Oh, that to
in a
be
way,
also a
and
search, right?
yeah. I'm sure the stack includes obviously the processing, and then the matching part obviously is with Elasticsearch. I think they use for for doing the actual match. So that's one application, and obviously we have other customers who use it for fraud, catching fraud, for example, in the financial services. In a way, from the AI part, from where most of um, eh, eh, the challenges was on the processing side. Like the inference was always going to be uh, m- uh, on the real time side because of the fact that of the requirements. It's the pre-training that where there's a lot more impact on the on how AI would be impacted by the stream processing.
Uh, cool. Yeah, thanks for sharing. And the next yeah, Sujay, can you show me just one
Uh,
example, okay?
Sure, just make it quick. I don't I think Ray has already covered quite a lot of these real-time cases there. I think we just can add on. We have been kind of working with one of the customers that is helping enterprise to kind of understand their physical operation, like mostly using camera and kind of using camera like computer vision technologies plus ML plus AI to really understand their operational intelligence, like things like staff engagement, parking utilization, and kind of few waiting times there. So I think everyone kind of moving towards in that direction to like using AI to kind of providing certain intelligence there. I think we saw it from our customer bases is that there is the AI is not just in the text spaces there. It's also kind of moving towards more real physical worlds, people kind of processing those unstructured data like image, video, and kind of getting these insights, intelligence out of those unstructured data
Hmm. Yeah, cool. So basically, it's more about the unstructured data, right?
there.
Cool. And all right. And we talk about for the I think what we just talked about for the rack, right? Well, we mentioned something about rack. So one quick question. I just want to make this question pretty brief. Do people still need to use rack? I think the answer is yes. But for the my real question is that okay, whether we always need to use rack. Um, Chang, can you give me some
Yeah.
brief answer on
Yeah,
this?
yeah, absolutely. So, not every problem is a RAG problem. So you don't always need to use RAG. I think the question is more about retrieval and context. And I think it's more useful to reframe
Mm-hmm.
the question on like when should you have retrieved context, or when you don't have to
Mm-hmm.
think about retrieval and put everything into the prompt, right? And um, the I think most of the time, and especially for multimodal data, I
Mm-hmm.
am when I talk to folks leading ML and AI applications in larger enterprises, a common refrain I hear from them is that almost every AI application problem they encounter becomes a retrieval problem at some point. Because if you think about
Mm-hmm.
enterprise data, there's way too much context to stuff all of that into an LLM prompt. And even if you could, it becomes super slow and super expensive. And there's no, it's like if you were to ask like what I had for dinner yesterday, and I recounted to you every meal I've had since birth, right? That's not a useful or efficient way to build an AI application. I think what where these long context windows become very useful is if the context that you retrieve, like maybe it's one document or it's a like a PDF or something like that. That document itself might be too long to fit into previous context windows, and you really need information from all over that document. So what long context windows give you is the ability to not have to worry too much in these initial stages about chunking and then feeding it the right passages and things like that, and just feed it the whole document. And if you don't know about the structure of the knowledge, if you don't know about like how to set up that retrieval problem, this can be an interesting like a way to get around that until you can build more. But to me, it's not like one or the other. It's that long context windows and retrieval actually work well together. And that means that companies can tap into even more knowledge that they have.
So,
Right.
and
And
in less, yeah, go
oh
ahead, go
yeah,
ahead.
I was just going to say kind of like when we think about like these real-time AI use cases with RAG and retrieve when you need retrieval-based content, this also really affects the streaming infrastructure, especially when things go multimodal. It's so one is the destination sometimes can change, which is like we're all familiar with processing click streams, right? But now click streams and weblogs can now go into an embedding process, an embedding pipeline, and then um, have to land in like a vector database, which I actually think that's an anti-pattern. I think given the fact that I'm building LanceDB, my answer is I think instead of changing the destination from your data lake to some like many different specific systems for AI, I think it's better to have a new AI data lake where all your AI data can land into. And then number two is when you're streaming data, the types of data and the weight of that data becomes different. So now many more companies are streaming like large pieces of text, audio, images, right? If you think about like customer support bots or something like that, right? You could have audio calls, and you could have images that people have uploaded, and all of that goes into these real-time data streams, and it becomes actually harder to process, I think, for if you don't set up the system correctly. But I think you guys are more the expert on that than I am.
So yeah, so I just want to ask a follow-up question because right, this sounds very interesting to me. You mentioned people ingest a clickstream to AI data lake. So basically, in LanceDB, I mean, did you see any real world or like yeah, people really directly ingest a clickstream into LanceDB? Did you see that?
So not clickstream directly into LanceDB, but if you think about previous pipelines where like clickstreams become part of like a personalization or recommendation pipeline,
Yeah, yeah,
right?
yeah. Mhm.
And so like that's user behavior that then goes into embedding generation pipeline, and then but a lot of it is okay. Those embeddings, instead of having to go to a separate system, they can directly go into your data lake in Lance format, which then allows you to run search and retrieval applications on top of those embeddings without having to move that data.
Oh, okay, got it. Actually, yeah, I have a follow-up question. So it's actually in a different slide deck, but when people build a rack, well, do they process it in real time or in batches? Well, when I say process, well, it actually definitely means, well, I mean embedding, right? Include embedding. So do people do embedding in real time, or they like, okay, let's just ingest the data, store it, things probably, I don't know, data lake, and then do the embedding afterwards, right? And probably at midnight, yeah, right? For batches, and then insert into a vector database. What are the typical patterns, role patterns? Yeah.
Yeah, is that a question for me?
Yeah.
Yeah.
I think Chang is you are the best one to answer that question.
Sure. Yeah, happily. So I actually see some sort of divide. So for RAG and agentic applications, it is almost always either real time or in mini batches. And then
Using real time.
so real time meaning like the user does something, that particular observation becomes embedded and then added to like to their Lance data set and LanceDB. Or it would be something like
And they call the embedding services in real time or in all micro batches,
yeah,
right?
so this would be like they call like it would be like the user adds a new document, then they uploads a new document, then they immediately go through their pipeline of like reading the data, reading the document, chunking it up, calling like OpenAI embeddings, and then adding that to LanceDB. And then once they add it, it becomes queryable.
Yeah. That's true. And yeah, definitely. So when yeah, that's true.
Yeah,
And
and then I think the other side of it is like semantic search. And so if you're building like even traditional like recommender engines, personalization engines are also being fundamentally transformed by AI. So now folks building recommender systems have like multiple sets of embeddings. Some are based on like collaborative filter embeddings. Some are from like the content from semantic embeddings and things like that. And so for those types of applications, they typically were larger batch before. And I still see a lot of them being batched. So like, once a day or like, I don't know, like once an hour or something like that, they would read a bunch of new data, do like a merge insert, and then re-embed a bunch of the new data. So I typically that's where I see the dividing.
yeah, cool. And risk will so I know that's what we actually in RisingWave we do here. We do CV yeah, this kind of like real-time pipeline, yeah, real-time AI pipeline. So definitely, as Chang mentioned, well, it's more about in real time or either in real time or micro batches. Well, basically it's real time. And can you tell me more about how people do that? Typically, where the data comes from and where the data goes to, and yeah, what the pipeline look like?
Yeah, so I mean, to answer your question on whether do it in real time or batches, it's obviously use case specific. For the ones that we are users who have RAG implementations where they use RisingWave is mostly because of the rich set of connectors we have, right? That allow you to ingest the data in real time and be able to process while the data is in motion. So in a way, we obviate the need for a lot of the things that they would have to build in terms of chunking the data, putting it in micro batches, and doing all that. So out of the box, you get a lot of that, lot of that functionality available. And then in terms of the actual use cases, one use case I could highlight is one of our early customers. Like they are Web3 vendor. They do a lot of the sentiment analysis on how the market is working. Reflecting because of the fact that there's so much of up and down with Web3. They're able to use the intraday information from different sources to bring in the data and reflect it in their dashboards, right? So that's one use case that I see where Not only are they calling OpenAI and embedding service to bring in, but they're able to incorporate that enterprise private data that they have, which is obviously stored in some of the Postgres databases. Some of it is coming from Clickstream from public sources. So it's almost like the data integration part and the processing part to provide the prompt to get the right answer. That plumbing is what we provide from RisingWave perspective for real-time RAG.
Cool. And for Sijie, so in StreamNative case, well, tell me some more about did you see people building RAG? And I mean, definitely for Kafka or for Pausa, I mean, definitely they are not RAG, for sure. Right? So I don't really think that's what you provide for vector search. But, tell me
In
about.
general, I think RAG is definitely kind of coming up with conversations there. But in general, probably RAG would only be relevant to kind of our spaces when people kind of doing this in real time in streaming, because then they would probably using us as kind of streaming ingestion there. So then they would get the data and then like using RisingWave to do probably certain processing, chunking, transformation, and kind of calling embedding services there. I think we are kind of more relevant kind of in the conversation is that for people who might be looking into use cases like they, for example, I think the question of kind of going down in a way is that if people are having latency requirements, they want to get that kind of private domain data in a real-time way to augment certain model. I think in that way, streaming ingestion plus stream processing probably more relevant in that context. But if latency is not that kind of important, I think micro batching, maybe doing bulk like RAG is probably more relevant in that spaces there.
Yeah.
So,
Cool.
Injun, I want to go back to your previous question just to add one comment about whether people are going to directly invoke LLMs or just use RAG.
Go ahead.
I know both will be applicable, but I feel like the RAG, as the trend towards more post-training increases, like in view of the recent developments, I feel like RAG gets even more prominence in terms of customizing to a particular domain, particular industry, or specific use cases will bring more value, I think, for RAG. Because I feel like a lot of the RAG use cases so far you see are anecdotal. Like we'll say, oh, you can do this, you can do that. But now I think the LMs are mature enough that you can get more value out of it. At least that's opinion at this point.
Yeah, definitely. I think well for domain specific, right? For I know that for LanceDB, right? Well, you guys Harvey, right? Well, give me give 30 seconds for a description about what they do. Yeah, Chang.
Well,
Yeah.
yeah, Harvey is one of the leading, if not the leading, legal tech AI companies, and they use LanceDB for highly scalable and very fast retrieval for multiple use cases, and essentially LanceDB was the only one that allowed them to not only enjoy the cost efficiencies of putting all their data on S3 and the scalability and the reliability that comes with that and durability, but also with LanceDB's architecture, able to get latency that's as if the data was stored in memory. And then in addition, I think what you're going to be seeing with LanceDB and our customers is that retrieval and just that vector search is just the tip of the iceberg, no pun intended, of like what you're going to need to do with your AI data to create a very compelling AI application. So if you, for example, you might need to create dashboards to track metrics internally or present results to your customers, then you need analytical capabilities to run on top of that AI data. You need to be able to do, for serving, you need to not just do search, but also just, key value, kind of key fetches And then in order to process that data to that final stage for serving, you need to go through not just embedding generation, but just overall data processing as well. And so those are all things that you can get with LanceDB because the storage is in one place, and rather than having to stitch 4 or 5 different systems together.
Well, cool. Super cool. And yeah, we have still so another question I do have is that when we talk about RAG and we talk about the embedding services, and my question is that will the embedding services fully replace feature engineering? Is feature engineering still necessary? Okay, I understand that you can always call the embedding as the part of the feature engineering, but okay, obviously I'm talking about the traditional feature engineering, right? So yeah, Riz, can you give me some explanation on that part, or do you think that people are still doing feature engineering, or you feel that's okay, everyone just call the embedding services?
No, absolutely, you need it. I don't
Uh,
think if we can do away with it. Obviously, uh, what I think is people should first look if their use case is well served by the embedding, like that reduces the pain having to build their own model, maintain it, and do all that.
mm,
And only then would you go and actually do the feature engineering. But I think it'll continue to be there. I don't see how the embeddings, the large language models, or any next evolution of this can address all of the ML workloads. So in a way, they will still be necessary. Now they will morph more into I guess in my own biased way towards more real-time based feature engineering, but they'll still be there. The tool set will change probably in some sense to fit those needs.
yeah. And actually, I want to add one more, and I think it's most of the data. Well, I mean, we still have such kind of so-called structured data, right? Well, I mean, even if you have unstructured data, you still have some structured fields, right? For structured data types, right? For and so that's what you probably want to stitch them together, right? And to probably get a better yeah, data quality, right? Um, so actually, the I can probably ask for Sijie for that for in StreamNative's case. So for StreamNative, you see people just processing, let's say, unstructured data, or they actually have, let's say, some like mixed data. Or I don't know whether it should be called as semi-structured, right? Well, I mean, because sometimes when people mention semi-structured, they say, okay, JSON. But for the but in StreamNative case, what kind of data type you ever seen and
I,
emerging,
I
right, for data, yeah, use
I
cases.
think in general, if data streaming is being used in like more business and operational side, it's more structured to a certain extent. Like
Mhm.
you want to have all these schema validation enforcement before hitting into your core business application, like payment processing, billing processing. All this has to be accurate because you don't want your system to be hit by a poison record there. So I think that is more leaning towards kind of a structured data or semi-structured data JSON, if you categorize JSON as a semi-structured data there. But if you're moving towards more like analytics pipeline, machine learning, AI, data engineering side, I think it became more like unstructured. It's just like you transfer raw text, but sometimes
Mhm.
still kind of semi-structured like JSON, like video, image. Those are kind of more unstructured data there. So it's kind of a mix. I would say 50%, 50%, like between these operational divide versus the inactive divide. Yeah.
Yeah,
Yeah,
totally
I
agree.
I I think like what I've seen for our users that like train large foundation models using Lance is that not only is feature engineering still a thing, but it's actually a bigger thing and it's harder on data
Oh,
infrastructure
why?
these days
Mhm.
because like it's not so much like feature engineering versus embeddings. Embeddings is a type of feature that people need, during their training pipeline. And so first, it's like to get to that embedding, you need to pre-process that data. You need to do data selection, data cleaning, data preparation. If you're talking about multimodal data, you need to maybe break down a video into frames and then like downsample and shuffle and crop and fill and all those sorts of things. And before when I was at working on like recommender systems for streaming, so there's like at Tubi TV, right? Like feature engineering jobs were like you kicked off a Databricks job and like it's finished in a couple hours. If it fails, you just kicked off again. And as long as it finished like before the daily model run, you're good, right? But if you're training a new foundation model, well, like for a given feature, it's like 2 days over like 50,000 CPUs or like 2,000 GPUs or something like that. You're not going to want to like restart that. So there's a ton of like additional management that then has to go into that of not just the job, but the data itself and how that data is processed and how you handle errors and retries and all of that. So I think if anything, like feature engineering becomes more important and harder to do.
Yeah, actually, you remind me of the paper from TikTok because well, I mean, I think last month well, a
Yeah.
lot of people talk
Yeah,
about
yeah.
TikTok, right? And TikTok actually have a pretty famous paper about their recommendation system, right?
That's right.
And
That's right. Yeah.
they actually use yeah basically the data streaming. Actually have the data streaming pipeline basically join the user. I mean the user feed stream yes along with some other data dimension data in order to I mean feed into the training model and no the basically the training system. So basically to do the online training. So in 2B, yeah, because you mentioned 2B, I mean, did you guys do the same thing? It's like more, yeah, not that fancy.
Similar. I mean, yeah, I wish we had the resources of TikTok. We couldn't get that fancy. So, but 2B TV, I think a lot of the success was because of its recommendation engine. It's all credit to the machine learning team there, and then also the experimentation culture that we added to it is we made it much easier for folks to run experiments and build confidence on these like bigger efforts, and all of that it has to be enabled by the right data infrastructure.
Sure, sure.
The
Yeah,
one thing
definitely.
I want to add is this notion of AI-ready data that's kind of
Mhm.
taking hold now with the organizations where just as in previously for BI workloads, people would design schema to answer the kind of queries that they had. Similarly, folks are now trying to organize the data in a way that's ready for model feature engineering. In a way, you don't do it on the fly, but rather make a conscious effort of how you process, how you store the data, which makes it even more conducive for feature engineering.
Yeah. All right, thanks for sharing. Yeah, we still have we only have 3 minutes left. And so one question I have is that well, what the role the S3 play in your product? Well, like well, I ask you this because well, you know that well nowadays well everyone talk about S3, right? When everyone says okay, let's build a product on top of S3. So what's the role? Yeah, well, what the architecture looks like, right? Well, give me a pretty just 1 minute, okay? Because we just have 3 minutes left, and everyone just give me 1 minute, okay? So Sijie, can you go first? Yeah.
Sure. I think in general, I think S3 is in the kind of storage role is playing kind of a cost reduction. So like in the past is like in Pulsar is acting as tier storage, so we can reduce the disk-based storage towards more cheaper options there. Moving towards like Ursa, like the entire design actually is also becoming a replication layer. So historically speaking, in data streaming, it has been kind of using like Raft, Paxos, or like ISR for replication, which is expensive because you need to replicate multiple times in inter-availability zone, and actually became coming out as you are able to kind of write to S3 in any availability zone, so it became the replication layer for the newer data streaming engine there.
Yeah. Cool. And the risk, can you yeah.
Yeah.
Also,
So
answer, yeah. Mhm.
I feel like she just told my answer. Our series also,
Okay.
in some sense, the same. We obviously, I mean, we are agnostic to the object storage layer, right? From a Rising Wave perspective, S3 or GCS or ABS, they
Mm.
also have the same purpose. Where the unique thing
Okay.
about Rising Wave is that for us, the object store is the persistent layer for the state itself, not just the
Oh,
data. So we store everything there, that has unique advantages in terms of how fast we can recover, how fast we can scale. So I think I know if you put all of the object stores in line, S3 is sort of first among equals in terms of how fast they are innovating and what they're doing. So I think it's obviously it plays a huge role in how we evolve our product, how much we can push it down to the object store in terms of backup, DR, all of the capabilities that you traditionally have to build for a product are sort of taken care, to be honest. And obviously the separation of compute and storage has cost and performance benefits as well, so that you can retain data longer term for a cheap cost while you can keep the compute small. So I think I can go on and on about it, but that's sort of the gist of it.
sure. And Chang, give me probably 30 seconds.
Yeah, absolutely. So in addition
Yeah.
to cost, it's about durability. It's about the integration into like authentication and scalability. I do think that people building these systems need to deal with more latency, more cold start, right, issues, and then kind of the issues around like managing small files and all the things that are the limitations of object storage. The goal of Lance is so that you're using S3 as a way to add AI data into your data lake rather than as a specialized system. So there are other vector databases that support storing your data on S3, but inevitably that becomes a black box that is not integrated into your overall enterprise data lake. And we feel that is missing a huge opportunity because for us, object store is real. The real potential of object store is creating this new AI data lake where your AI data is not just serving one use case, but many from training to analytics to search.
Yeah, so basically, Lens is the
I'm
Parquet
not sure
for
if that
AI.
was 30 seconds, but hopefully it wasn't, I didn't go over too long.
All right. Yeah. Parquet for AI. Okay. I can understand that. Well, yeah. All right. Well, thanks for you guys for sharing, and definitely we learned a lot about all the data and AI, right? For the real-time data and the AI applications and racks and S3, right? Well, and okay, that's super fancy. And yeah, thanks for sharing. And let's yeah, because we are running out of time. I actually have actually some more questions, but well, definitely we could not have enough time to discuss that. But well, anyways, thank you for attending the webinar. And if you're interested, definitely reach out to the panelist, and we can have more discussions offline. All right.
Thank you,
All right.
guys.
Thank you, guys.
Thank you,
Sounds great.
everyone.
Thank
All right.
you.
Thank
Bye
you.
bye.